Let's take a look at another law. Here's the combined gas law once again. This time, let's now assume constant pressure. Let's say pressure in the initial condition over here on the left is 1 atmosphere, and the pressure in the new condition here on the right is also 1 atmosphere. Well, if they're both 1, let's just cancel those out. What do we have left in the equation? We have V1 over T1 equals V2 over T2. This law is known as Charles's law. Who came up with Charles's law? Dr. Law. Good. Let's see how some numbers work out here. Let's say we have an initial volume of 2 liters and the temperature was 100 Kelvin. Let's say we've changed the volume down to 1 liter. What is the new temperature? Can you figure it out? You can do cross multiplication or whatever works best for you. Over here we have 2 over 100, that's 1 over 5th, same as 1 over 50. So T2 must equal 50 Kelvin. Right. Notice what happened. We cut the volume in half. What happened to the temperature? It went from 100 to 50. It was also cut in half. So according to Charles' law, if you decrease the volume, you decrease the temperature. Or you'll also find if you increase the volume, you must increase the temperature. That is to say that volume and temperature are directly related. Right? Increase one must increase the other. That's Charles' law. And here we've reached the final gas law for today. Again, combined gas law. New situation. Now let's assume constant volume. Constant volume. If the volume's the same, you know what we can do. We can cross it out. And what are we left with? P1 over T1 equals P2 over T2. This law is called Gay-Lussac's law. Who came up with it? Gay-Lussac. All right. In this situation, let's try some numbers once again. Let's say the initial pressure is 2 atmospheres and the temperature was 20 Kelvin. Let's say that we don't know what the second pressure was in the new condition, but we know that the temperature was 50 Kelvin. What's P2 equal? Right? Whoops, that's supposed to be a question mark. Right? What does P2 equal? Well, on the left, 2 over 20, that's 1/10. What would make this true? Blank over 50 gives us 1/10. Did you figure it out? That must be 5 atmospheres. Again, you can cross multiply or just take a look at the proportions. They need to be the same. Now, what happened when we changed the temperature? We increased the temperature 2.5 times. What happened to the pressure? It went up by a factor of 2.5. So, if you increase the temperature, you increase the pressure. Or if you decrease the temperature, you're going to decrease the pressure. Again, just like with Charles's law, the two variables are directly related. In Gay-Lussac's law, pressure and temperature are directly related. You increase one, you increase the other. That's Gay-Lussac's law. Let's review. The combined gas law, the first law we took a look at. In the initial condition, the pressure times the volume divided by the temperature, that's for the initial condition, is going to equal the pressure times the volume divided by the temperature in the second condition, or the new condition. The units for pressure have to match, the units for volume are going to have to match, same thing with temperature. Temperature will always have to be expressed in Kelvin. Boyle's law now assumes that the temperature must be held constant, so we can rule out temperature from the combined gas law. What we have left is P1V1 equals P2V2. In other words, the pressure times the volume in the initial condition is going to equal the pressure times the volume in the new condition. Charles' law. With this law, we assume constant pressure. So if pressure is taken out of the combined gas law, we're left with V1 over T1 equals V2 over T2. All right. We see that if you increase the volume, you're going to have to increase the temperature. Or if you decrease the temperature, you must decrease the volume. In Boyle's law, it's a little different. Very different. If you increase the pressure, you must decrease the volume. So pressure and volume are inversely related. Temperature and volume, however, are directly related. We go to Gay-Lussac's law, and in his law, we assume that the volume is held constant. So what we're left with is P1 over T1 equals P2 over T2. What kind of relationship exists between pressure and temperature? If you increase the temperature, what must happen to the pressure? It must also increase. So there's a direct relationship between pressure and temperature according to Gay-Lussac's law. Now how do I remember these? Well, always got to remember pressure and volume always belong in the numerator if they're involved. Pressure and volume always in the numerator. Temperature is the only factor that belongs in the denominator. Right? So how do I distinguish Boyle's from Charles from Gay-Lussac's law? Well, when you're boiling mad, you might be peeved. Or I'm a baseball fan. Jake Peavy was a great pitcher for the Padres. I remember watching him pitch because when he wouldn't get a strike call from the lousy ump behind the plate, he'd get boiling mad. So Peavy always got boiling mad. All right. Charles. There used to be a lame television show called Charles in Charge. It was on TV. Charles was on TV. All right. Charles' law talks about volume and temperature, or temperature and volume. Gay-Lussac's law, you can figure something out. I'm not going to touch that. Those are the gas laws. Hope you enjoyed the lessons. We got some problems to work out next time.